I would like to explain the last two theorems in section 10.4. The first theorem I have here is if an inscribed angle intersects a diameter, then its measure is 90 degrees. This is theorem 10.8. What I did is I drew a circle and I drew the diameter AB. And you notice that right here, AB goes across right here. All right. And right across here through the center. And what I did at that point is I drew actually 4 inscribed angles, 2 black ones, a blue one, and a red one. And what do you notice about each of them? Well, they're all 90 degrees. And why is that true? Well, an inscribed angle is half of its arc. So if the arc AB is 180, and it has to be because it's a semicircle, then every one of these angles has got to be 90. Okay? Very kind of a fascinating theorem here. In fact, we're going to be doing a number of problems using this concept. So if an inscribed angle hits a diameter, its measure has to be 90 degrees. Please refer to problems 8, 9, and 10. Problem Q, therefore, must be, problem number 8, the angle Q must be 90. Problem number 9, angle M must be 90. And let's see, yeah, that's how you do those two. I'm just looking at number 10, seeing if that's as similar. Yes, number 10 is also a similar situation where angle B has to be 90 and also angle D has to be 90. So if an inscribed angle intersects the diameter, intersects a diameter, of course there are infinite numbers of diameters, then its measure must be 90 degrees. The black and the blue and the red angles are all 90. And I might just draw one more here just to make this point clear. I could draw an angle here. As long as it's an inscribed angle, this angle right down this corner must be 90. Kind of fascinating. The last theorem for today is theorem 10.9. Theorem 10.9 says the sum of all the interior angles of a four-sided figure is 360, and therefore the opposite angles must be 180. Now I've made a little change to the theorem, but basically that's what's happening here. So if we think about this, if I think about this inscribed angle here, since that includes this arc, then if I look at this inscribed angle here, that includes this arc. I just went all the way around the circle, didn't I? That implies that if an inscribed angle is half the arc and you end up going all the way around the circle, then opposite angles must be supplementary. Again, kind of a fascinating thought. Draw any four-sided figure inside a circle. Opposite angles are supplementary. So here I have angle A supplementary to angle C and angle B supplementary to angle D. Now you're going to use this theorem to solve problems like number 27, 28, 29, and 30. For example, problem 27, angles W and T are supplementary. You know what that means. Their sum is 180. Angles R and Z are supplementary. 29 and 30, angle H and K are supplementary, as are J and G. Your assignment for tomorrow is going to be problems 1 through 30. You're not going to do problem number 4, nor are you going to do problem 7, nor are you doing problems 21 and 22. I think this is a reasonable assignment. Okay, do your best.